Okay, this is the third video on SPSS. Let's see what are we going to do today. Today we will see the typical univariate analysis technique. So these are the techniques which let you analyze a single variable. So not the case when you have two variables and you are trying to discover the relation between the two variables, but the case when you have to analyze, to make usually a descriptive analysis, but sometimes we'll see also the statistical test on a single variable. Usually it's the first thing that you do just after having inputted the data. Or in the course of SPSS of last year, at this point I started teaching how to build new variables and modify existing variables. This part, however, is very technical and very boring, so I've moved it right at the end of the course. So we start with statistics, with the univariate analysis techniques, and we'll deal at the end of the course the more technical part. For the typical univariate analysis technique, you have a table, this one. You will have a similar one for the bivariate analysis technique. I strongly suggest to print this table very large and to carry them with you at exam, because at exam usually I do not explicitly ask you, do the student t-test for one variable. I just give you the variable and I tell you, test this and this and this, and you should be able to pick up the right test. Or I just give you a nominal variable and I ask you, please provide the true graphical description, and you have to produce a bar plot and a pie chart. If you produce a box plot, it's wrong, clearly. So this tables helps you a lot. It will help you also in case if you have to do real statistical researches or small surveys, because they help you, they tell you what can you do with the variables that you have and what can't you do. Okay, let's start with descriptive statistic frequencies. It's a tool for nominal variable. It's a numerical description of nominal variable. You will see it's very simple and very obvious. Please open SPSS, this one. And open also the example data all file. You can simply drag them on SPSS if I can find it. Okay, this is the usual file that we will use throughout this course 99% of the times. It contains data collected from 2006 to 2011. The variable structure is already well defined and perfect, so there is no mistake in it. There may be inputting mistake. Okay, let's start. Frequencies is here. Analyze descriptive statistic frequency. It's a tool to provide a numerical description for a nominal variable. So let's find a nominal variable. For example, the town of birth, okay, but also sex, and also the favorite subject. Okay, these are all nominal variables. Please flag display frequency tables and click OK. You will see what does it provide. The output opens up. This window is another window and also another file. It needs to be saved separately. Okay, it's the output window. First of all, it just tells you what have you done. You have done frequencies, variable, town, sex, favorite. Okay, this helps me correct the exam, so do not delete it. Okay. It's just a brief overview on the data that you have. You have 200 valid data, no missing for town of birth, 186 valid data, and 14 missing for favorite subject. Well, this is exactly what you imagine. You see that 5 people come from Berlin, 70 from Bozen, 12 from Brixen, 2 from Dresden, etc., etc. The percentage, so 35% of people come from Bozen. Okay. Valid percent is the same thing, but excluding missing. In this case, there is no missing. Okay, sex, 92 male, 108 female, 46 male, and 54 female. Okay. Favorite subject, 5% of people like statistics, 23 economics, 18 accounting, 17 marketing. You can see here the valid percent is different because we have 14 people missing, and the valid percent doesn't consider it missing. Okay. You could ask me why there is nothing to do for ordinal variables. Ordinal variables can be considered both as nominal or as a scale variable. Officially, they are nominal variables. Okay, so you can do everything you can do with a nominal variable, could be done also with an ordinal variable. However, when the ordinal variable has many categories, you could make the assumption that it's a scale variable, and so you could also apply the scale techniques. In this case, you are assuming that the distance between very low and low is the same as the distance between good and very good, for example. So you are assuming that it has a mathematical meaning. Okay. There are some cases where there is clearly no mathematical meaning. In that case, do not assume that it's a scale variable. For the exam, obviously, I will clearly specify, whenever you have to work with an ordinal variable, whether the variable should be considered nominal or scale. If you look at a past exam, usually between parentheses I write considered as nominal or considered as scale. If you do research on your own, the basic rule, few categories nominal, many categories, and with a slight mathematical meaning, scale. Okay, we have seen frequencies, so let's ask for frequencies also for a nominal variable, an ordinal variable. If you click reset, you will clear up the dialog box. University grade. You can see here a tree builds up with what you have done. Okay, here you can see very low, low, average, good, very good. Okay. There's also the cumulative percent, which in this case makes sense. You can say that 42% of the people believe the university is very low to average. Okay, so very easy. Frequencies have also another important consideration. They can be used to easily spot mistakes in your data entry. And this is the only case where I recommend to use frequencies also for scale variables. So if you take all your variables, and I mean really all, and build frequencies for all of them, and then you carefully, slowly analyze step by step each variable, you can easily spot data entry mistake. For example, for the ID, you know that they must all be different. So if you see a frequency which is not exactly 1, that is clearly a data entry mistake. Let's see. In this case, they all seems to be correct. If you see here, year of submission, 2015, well, it's clearly a data entry mistake. Also, first day of elementary school, if you see 55, well, data entry mistake. Also here, people who say that have started elementary school in January, May, and July, please let me have doubts about them. Maybe these are data which needs to be rechecked. And also this one, who says that he started elementary school in 1914. Okay? It's clearly a data entry mistake, or a person who has cheated with the answer. So, here if you see male, female, 7, probably you have typed a 7 instead of 1. So data entry mistake. So it's very good to spot easily data entry mistakes, and also for the other category to pick up which is the most, for example here bicycling should be included. Here business studies should be really included. What's this? Obviously, if you ask frequencies for things which are scale, such year of birth, you will have many categories. Look at the last one. Here. You see many categories, and also number of passed exams, probably here. You see many categories. Also, let me have doubts on this 90 exams, and also on this 1 through 9. Okay, let's go on. Descriptive statistic descriptive is the same tool, but this time used for scale variable. For scale variable, you could ask for frequencies, but it doesn't make sense. You get an endless table full of 1, 1, 2, 1, 2, 3, 1, 1, 1, so it doesn't really make sense. Let's ask instead for descriptive statistics. Analyze descriptives. Okay. Descriptive statistic for year of birth and passed exams. Here it's a good idea to take a look at options. Here you can see which descriptive statistic do you want. The mean, it's the average. Standard deviation, if you want also the variance. Okay, minimum, maximum, kurtosis, skewness. It's the basic list of descriptive statistics. Let's ask for these ones. Continue, okay. And you get the descriptive statistics. Year of birth, minimum 1907, maximum 1990. Here you get that there is a mistake. An average of 1984,73, standard deviation 7,617, variance 58, and also passed exam. Something you should have seen in statistics A. Okay. Now, let's go here. Non-parametric test. The difference between parametric test and non-parametric test is pretty technical. So it's a technical statistical issue, and I will not go through it. Okay? You have no problem doing the exam without knowing it, because you have the tables. So you know when I ask for a parametric test, you know that I want this one. When I ask for a non-parametric test, you know that I want this one. Okay? If you are curious, there is my advanced statistics handout, and you can look inside it. A chi-square for a one-dimensional contingency table. This is a test which checks whether, you can see always I always write H0 to tell you what does the test really do. This test checks whether the distribution of the categories is predetermined or not. Let's make a clear example with an easy one, sex. Okay. I make the hypothesis that my population, so my student population, is divided male people 40%, female people 60%. Okay. So this is my H0 hypothesis. So my classification for male, female is 40%, 60%. I want to test it. To test on my sample, I use this test here. Where is it? Okay, crosstabs. No, sorry. Non-parametric test, one sample. So, analyze. This is the new dialog of non-parametric test. Until SPSS 16, the dialog was rather different. If you want to use the old one, you can, if you find the same thing. This one should be here. One sample. Unfortunately, SPSS has the bad habit with non-parametric tests to decide himself what to do. It's something which I really dislike. So don't let him decide what to do. He will perform a lot of tests, and I will mark it as an error. So if you do more tests than what is necessary, error. So please, no automatic customized analysis. We decide what to do. Okay. Please remove all these ones, because SPSS decides to do everything. Okay. We need only a test on variable sex. Okay. Settings. Customize test, we need to do the chi-square test. Okay. Compare, observe probabilities to hypothesize. So my hypothesis is that the male are 40% and female are 60%. Okay. Options. I must tell him my hypothesis. So category, male, 40%, 8 the comma, category female, 60%. Please become know very well whether your SPSS needs the comma or the dot, because you can commit mistakes. Okay? Run. Does it arrive? Okay. Retain the null hypothesis. It means accept. Okay. It gives me my significance, which is 8%. It's above 5%, so I accept the null hypothesis. Okay. It means that my category distribution could be 60%, 40%. Okay. At the exam, for those of you who are worried mostly about exam, I would ask you, test whether sex is distributed 40% female, 60% male, or whatever. Okay. You should only do this one. You don't need to explain to me that this is the significance that you accept, etc., etc. It's not important for this exam. Okay. So you should only do the exam. You should not, if you want, but there is no need at all to give me statistical justification and statistical conclusions. Okay. It's not a course of statistics. You can see that in the meantime, SPSS has kindly built up here a little tree of what I've done so far. Okay. Let's do another test like this one. Please test whether the number of people who say very low is 20%. The number of people who say that university is low is 20%, average 20, good 20, and very good 20. So check whether the answers to the question, how do you rate this university, are uniform. 20%, 20%, 20%, 20%, 20%. Let's see how to do it. Analyze. Non-parametric test, one sample. Field, university grade. Settings, chi-square test. Options, all categories have equal probability. So 1, 2, 3, 4, 5 have 20% each. Run. Reject the null hypothesis. It means that according to SPSS and to this test, the people are not divided equally uniformly among the 5 categories. Okay. Let's do the same test for the favorite subject. I will ask you, check whether the distribution of favorite subject is uniform. So, 1/6, 1/6, 1/6, 1/6, etc., etc. Fields, favorite subject, settings, chi-square, options. All categories have equal probability. It's exactly the same if you choose this one or you specify category by category. The categories are 7, because there is also the known category. So 1/7. Okay. Let's calculate 1/7. 0.14. Etc., etc., etc. So, okay. And you go on with other categories up to 7. So it's exactly the same. Clearly here it's much faster. Okay. So, this test has 2 versions. You may test whether the distribution is uniform, so each category has the same percentage. In this case, you just don't need to specify any percentage. Or you can check whether the distribution is given. So, at exam, I will give it to you. Okay. In this case, you need to specify it. Okay. Okay. Let's talk about a student t-test for one variable. It's the test that we use as an example when 2 lessons ago I explained to you how does a statistical test work. Okay. So it's a test which checks whether the average of a scale variable is a certain value or not. Okay. It checks whether the expected value is equal to a certain value or not. I will now ask you, please check whether the average of year of birth could be 1984. Let's see it. Analyze. Compare means. One sample t-test. Year of birth. Test value 1984. Don't leave 0. 0 is wrong. You're testing whether the average is 0. Clearly it's not. And here the test. If you are curious, this is the significance of the answer of the test. It means that you have to accept. So it could be 1984. Okay. Okay, however, at the exam you don't need to explain to me anything, you just perform the test and you're okay. Now, test whether the average, the expected value for passed exams could be 25. Analyze. Compare me one sample t-test. $25. Reject. It means that the computer is sure that it's not 25. In fact, on the sample it's 23. So 23 is too far from 25. The computer is sure that it could not be 25. Okay, so pretty easy test. There is nothing to do. Remember to specify the value. Okay. There are only 3 tests where you need to specify the values, are the first 3. The other ones don't need to specify any value. Okay, and finally, a very similar test, the sign test. The sign test is very similar to student test for one variable, with the difference that it does not test the expected value, but it tests the median. Okay. You should know the difference between average and median, or between expected value and median. It's a very famous difference in statistics. There are many typical examples, and I will not tell it to you. Okay. It tests whether the median is a certain value, or could be a certain value, or not. Let's do it. I ask you, please check whether the median of passed exams could be 25. Here, I suggest to click Reset to clear up everything which you have done so far. Otherwise, SPSS always remembers what you have done before. So Reset. Objective, Customize Analysis. Field. Remove every field and choose only passed exams. Settings. Please do not automatically choose the tests. Okay, otherwise you will choose the wrong test or some tests which are not necessary, and I will mark it as an error. Okay, where is the median, the sign test? Unfortunately, according to the version of SPSS, or according to whether the variable is scale or ordinal, SPSS calls this test in 2 different ways. So sometimes you see it's called binomial test. I have seen myself with my own eyes on other SPSS being called sign test. So either binomial test or sign test. It's the same test. Don't ask me why SPSS calls it in 2 different ways according to the computer or to the SPSS version. Okay. Options. Custom midpoint 25. So please remember, it's hidden here, it's not here. Don't click on strange things here, don't specify anything here, it's here. Okay, so don't touch around unless you want to have a deeper knowledge of this test. Please click here. So we are testing whether the median could be 25 or not. Run. Significance 0, reject. It means that the median for sure it's not 25. Okay. A similar one, test whether the median of hours passed at the university during exam months is 3. So, analyze non-parametric test, one sample. Of days, sorry, not hours. Okay, reject. Using the new format of the non-parametric test is very friendly and graphically attractive, but I really prefer this one, which tells you much more information. Okay, so we have done everything here. We have done this once, this one, and this one. The graphical description will be done later, all together with all the other graphs. As a homework, you have this little exercise, describe variable com, describe variable mates. With describe, I mean give a numerical description, because we have not done graphical description so far. Is variable university grade distributed uniformly? Number of past exams significantly different from 22? Here there's a mistake. Is the average of past exams? Okay. Otherwise, are the people who play football significantly different from the people who do not play football? Okay. Let's do together only the last one. Okay, if you are looking at the video, first do it, so suspend the video, and then look at the solution. Okay, now the solution. Are the people who play football significantly different from the people who do not play football? Okay, playing or not playing football is a yes-no question. Okay. Here I am asking you whether 50% of the people, whether you can make the hypothesis that 50% of the people play football and 50% of the people do not play football. So how the amount is the amount of people. Okay, save. Okay, so how do we check it? Well, this is clearly a chi-square test, okay, and with 50%, 50%. So only two categories, 50%, 50%. So it's here. Let me remind here. Not this one, this one. The field is not this one, it's football. Options. All categories have equal probability, or if you prefer, you customize them. It's exactly the same. It gives exactly the same result, and both are correct. This one is longer. Let's see. No, it says that there is a significance twist, so it's not exactly 50%, 50%. We don't know in which direction the twist is, whether there are more people playing or more people not playing, because, as you can see, the new graphical format doesn't tell us anything. Okay. Bivariate analysis technique. This is an analysis technique which let you check whether there is a relation between two variables. Please do not call it correlation, it's a relation. There is a big difference, because correlation in statistics, it's usually linear correlation. So it checks whether, this test checks whether there is a relation between two variables. According to the type of variable involved, nominal and nominal, binary nominal, so a nominal with two values and a scale, non-binary nominal, a nominal with more than two values and a scale, or scale and scale, there are different descriptions. With description this time I mean both graphical as well as numerical descriptions. Parametric test, non-parametric test, and this time we have also forecasting tools, because you can use one variable to forecast the values of the other. Okay. You probably have heard of regression model. You use one or several variables to try to forecast the values of the other. Okay, let's start with the simple one. This one, nominal and nominal. So here the situation is you have two nominal variables. Imagine, for example, sex and favorite subject. Okay, we all can make the hypothesis that there is a relation between sex and favorite subject. For example, I imagine that female subjects don't like computer science as much as male subjects do. It's traditionally a male subject. So there could be a relation between these two variables. Okay. So let's check immediately whether there is a relation between these two variables. Analyze descriptive statistic cross tabs. Even though the test is called chi-square test, okay, also this test is called chi-square test, unfortunately it's not here. So don't look for it there. It's much better to pick it up from here. So first of all, we will analyze graphically and numerically the relation between sex and favorite subject. Then we will perform a test to check whether such a relation exists or not. Okay. So this tool builds up a table, basically. So rows sex, column favorite subject. It's a table with sex in the rows and favorite subject in the column. For the moment, don't click on anywhere, just OK. Ignore this table, which is just a summary. Here, you can see that male subject, 5 male subject like statistics, 6 female subject like statistics, 19 like computer science, and only 8 female. Okay, and you can see all the values. However, unfortunately, these values do not tell you anything useful. Why? Well, many people commit the mistake of claiming that male don't like statistic as much as female. So female prefer statistic. It's wrong, because male are 5, female are 6, but also male are 86, female are 100. So it could be that this female here are one more only because there are many more. Okay. Here, on the other hand, it's very clear that male prefer computer science and female do not. Okay. But in situations like here, or even here, accounting, it could be that 2 less, it's only because there are fewer. Okay. So in order to correct this thing, you need percentages. So redo it, please. This time, go to Cells and click on Row Percentages. And let's see what do we get. You have the percentage within sex. And this time it's very clear that 6% of female like statistics and 5.8% of male like statistics. So more or less the same. Here, even more clear, 19% of female like accounting and 19.8% of male like accounting. So even though they are less, they have much more impact. Okay. While also here, 8% of female like computer science, 22% of male like computer science. So asking for the percentage within here row, so row percentage, helps us clear the matter which these numbers are unable to solve. So usually when you build a cross tab, a contingency table, this is also technically called contingency table. Where is the output? Okay. You should also include percentages. The question is, which percentages? The row percentages or the column percentages? It depends on what you have to prove. In this case, I had to check what happens within sex. So row percentages are perfect. Let's see what happens instead if I ask for column percentages. Go to cell, no row, column percentages. it is telling to me that among all the people who like statistics, 54% are female and 45% are male. Honestly, this percentage is totally useless for me. Okay? You cannot compare it. Okay? So, depending on what you want to prove, you may use the row percentage or the column percentages. Okay? Let's remove the percentages. Another thing which is interesting, go to statistics. If you click on chi-square, you automatically, without any extra effort, get the chi-square test. So if you want to build the chi-square test, you don't need to go into another menu. You build the two-dimensional contingency table, and you click on chi-square inside the statistical option. So statistic chi-square. It's a test which checks whether the classification is independent. So whether there is no relation between the two variables. Let's do it. You can see it repeats the table, but it adds this little thing, chi-square test, with the significance 0.065. In this case, it tells us to accept. So there is no relation between the two variables. So according to the test, there is no relation between sex and favorite subject. Okay. For those of you who are interested into the technical details, there is a little problem. Two cells have expected count less than 5. It's a technical problem. It's a technical statistical problem, but we will not talk about it here. So this test checks whether sex is related with favorite subject. Okay, the answer is here. And it's done together with the contingency table. It has no meaning doing it alone. Usually it's always together with the contingency table. So, two-dimensional contingency table and chi-square for a two-dimensional contingency table. Okay. Okay. So let's see some tests and tools for a binary nominal and a scale variable. So I'm referring to this case here. So you have a binary nominal, for example, sex, and a scale variable, for example, passed exams. Okay. We are interested in checking whether there is a relation between these two variables, so between sex and passed exams. We may claim that female students, for example, pass more exams, or vice versa. First of all, we'll use a description, so we just compare the means. We compare the average of passed exams for male students with the average of passed exams for female students. Let's do it. Analyze. Compare means. There is a specific menu. Click here. Dependent list. Into dependent list, put the variable for which you want to calculate the average, so the scale variable. In the independent list, put the variable which divides your sample into groups, so in this case, sex. Okay, so the binary nominal should go here, and the non-binary nominal should go here. Okay? After some calculations, you see here, the mean for male is 23.85, for female 22.86. They are very close, and we may claim that there is no significant difference. Okay? Well, however, in order to check it from a scientific point of view, we need to do an appropriate test. The test is this one, student test for two population. It's the test which checks whether the difference between the two averages is significant or not. It's here. In fact, its H0 hypothesis is that the expected value on male of variable passed exams is the same as the expected value of variable passed exams on population female. So the female and male have the same expected value. The alternative hypothesis is that they have different expected value. Let's do the test. Analyze, compare means, pay attention, it's here. It's not here, which is the previous one, it's here. Independent samples, the test. Okay, the interface is identical to the previous one, so you just put passed exams here, and you put sex here. Okay. You can see that you can perform the test on several variables at the same time. SPSS will perform different tests. So if you put here 5 variables, SPSS will do 5 tests. Another thing, unfortunately, SPSS cannot distinguish which categories sex has, so we have to tell it to him. So define groups, 0, 1, continue. Okay, now just press OK, and you get the t-test. If you compare this output with the previous one, the one for the non-parametric test, you will see that this is the old style output. It provides you a lot of information, which are very useful, but does not explicitly write you accept the null hypothesis, reject the null hypothesis. You have to interpret it. It repeats the mean very kindly here, the mean for male and the mean for female. The result of the test is here, significance of the t-test. There are 2 significances, usually they are quite close. Okay. Both are well above 5%, and so it should be accepted, so there is no significant difference. Okay, a very similar test, a very similar tool and a very similar test is the case when, in the case when you have a non-binary nominal. For example, favorite subject. Okay. In this case, we always have compare means, which is the identical tool, is the same. The test changes name, it's called ANOVA, but it's practically the student t-test for 2 populations. There is no difference from your point of view. From a technical point of view, there is a large difference. Okay, let's try to do it. Let's see whether the favorite subject influences the average of passed exams. Analyze. Compare means. First of all, we will ask for the means, just to have an overview, a qualitative overview almost. Passed exam still here. Instead of sex, you put favorite subject. A nominal variable, however, with 7 categories. Okay. In fact, you get the mean for favorite subject. You can see that students who like computer science pass more exams. Well, also students who don't like any of this this subject passes more exams, but they are only 2. I would doubt that this average is really significant. Let's perform, however, a specific test, the one-way analysis of variance, simply called ANOVA. It's a test which checks whether the expected value of passed exams is the same on all populations. So it checks whether there is at least one significant difference or not. Analyze. Compare means one-way ANOVA. Factor. Favorite subject. In this case, you don't need to specify the categories. All the categories will be included. Passed exams. Okay. And this is the result of the ANOVA. It does not